Hi friend, this is Shomi Vishwash. Today, that is the last class of that circuital theorem, and my today's topic is Millman theorem. So it is Millman's theorem. So what is the application of such things? Suppose I am taking one example. Suppose question number 1, it is given, that is 5 ampere, and here it is just 2 ohm, that is 3A, and the next one is 2 ohm, and the last one is 1 ohm, and that is RL. So you have to find out the current through this RL using this Millman's theorem. So before that, how can I judge this? The Millman's theorem, the process is what? First of all, you have to change that current source into this equivalent voltage source. So here it is 10 volt with that particular 2 ohm right here. Again this is same 2 ohm there, and this is 6 volt, and that is a RL. Okay, so what this theorem says that this is you have to know as V1, this is you have to know as V2, and this is the R1, and this is the R2. So first you have to convert R1 equals to 1 by G1, or G1 equals to 1 by 2. In the same way, G2 equals to 1 by R2 equals to 1 by 2. So what is the V Millman? You have to find it out. What is V Millman? I just write an V mill. So that is V1 G1 plus V2 G2, it more so like this, plus V3 G3 V4 G4 like this, divided by G1 plus G2. If it is something more, then there is G1 plus G2 plus G3 up to Gn. So here it is V1 means it is 10 volt plus 6 volt into G2 divided by half plus half. So this is 5 plus 3 by 1 equals to 8 volt. Okay, so what is the final circuit by this? You may have, that is 8 volt plus minus, that is R. Here R is what? R is 1, and that is RL. So that is RL, it should be 1. Now why R equals to 1? That R is simply the value of this G1 plus G2. This particular value is shifted with that R. So R equals to G1 plus G2. So if you are adding them up, so finally the current is I is 8 volt by 2 equals to 4 ampere. Now as I am telling in the previous classes, that always clarify this particular one using some different rules. Okay, now let's find the RL with that use of superposition theorem. How to do this? First of all, you have to find out current for 5A. So 5A current is taking the branching as 1 by 2 dot 1 by 2 dot 1. So finally that is, if you are taking K, so it is 2k equals to 5, so k equals to 2.5. So the current through this particular branch for 5A, it is 2.5 ampere when this is open. Okay, again we should make it active and make this one as open. So what is the current then? It is 3 ampere. The two arm is 2 is to here 2 parallel 1, so it dividing into 2 is to 2/3. Okay, so 2 is to 2/3. So finally what is the current in this 2/3 branch? You have to find it out by using this formula, that 3A into 3A into 2 by 2 plus 2/3. So that is equals to the current divided by, actually I am using 3A into 2 by 8 into 3, so it is 3A, and this is 3/4. Okay, again this 3/4 of this is taking its division into 2/3 and 1/3. So 2/3 current will be passing to this, and 1/3 because the total resistance emission is 3. So 2/3 current will be passing on this lower resistance having larger current, and the larger resistance having lower current. So 1/3 will be passing on this. So 2/3 of this. So 2/3 of this, you can see that is 2. It is 1.5 ampere. So both are supplying current in the same direction. This is the direction actually, so it is additive. So final current I equals to I1 plus I2, that is equals to 2.5 plus 1.5 equals to 4 ampere, and you can see those two are the same answer. So using some other theorem can make some solution, using some new theorem like Millman's theorem, Thevenin's theorem, whenever you are applying. So please tally the result using more 2 or 3 formula to get fully clarified that yes, what I have done, that is okay. And these things can be again judged with that help of tree structure, with that help of 2-port network. It will be coming later on. So here the answer is been given. That is a question for a DC circuit, that is a question for DC circuit. So here I have prepared another one, that is find out here this particular problem, that find out Millman equivalence of this particular circuit. So how to do this? First, step 1, you have to convert it, that is 6 volt and this is 4. So it is already converted. Here it is 1 ampere and it is 2, so it is converted into 1 volt into 2, like this 1 volt series with 2 ohm resistance, and finally it is open. So what is G1? G1 is 1 plus 1 by 4, that is G2 is half. So here V1 G1 V2 G2 by G1 plus G2, simply we are using, that is 6 cross 4, 1 by 4 plus, simply here why it is 6, because this is 6 volt, so it is 6 cross 1 by 4 and plus V2 G2. Here what is V2? It is 1 volt, so that is V1, that is 1/4, so that is 4, that is 6, and this is 1 ampere, so it is 2 volt. It is 2 volt, because if I multiplying this, it is 2 volt. So 2 volt into cross half, so it is 1 and it is 2 3, so 3 by 2 plus 1, so it is 5 by 2 and this is 3, so all total this is 10 by 3 volt. Now what is R? R equals to 1 by G, so you can simply doing this, you are getting this particular one. 4/3 here in the same problem, that is 1, so R equals to 1 by G. I have just placed this value right here, so it is 1/4 plus half, so obviously it is 4/3 ohms. So what is the final Millman circuit? That is 10 by 3 series is 4/3, and that this point will be the Millman equivalent circuit. So that is an example of that Millman's theorem in that AC application. So those who are attending this particular class, please see that is a Millman's theorem. What I have done in this class, that is a Millman theorem. So I have applied the Millman's theorem for solving this type of problem. Again, in my copy I have shown you some other technique can be followed by that superposition here, and using the superposition I will be getting the same answer here, that is 4 ampere here, and here the answer is same as 4 ampere. So you are telling this two formula whether it is correct or not, and after that in the next example I have shown you that find out Millman equivalence for this type of circuit. Here I have just converting this current source into a equivalent voltage source, and this is already there. So finally I am getting G1 G2, and this value is this in front of you, and that is the Millman's equivalent circuit here. That is 10 by 3 volt and 4 by 3 ohms are connected. So that's all for this Millman's theorem. So you should find out more problems from your textbook, whatever textbook you may follow, and practice it out. Lot practice is always makes you very perfect, and always try to shuffle this theorem from one theorem to another theorem, another theorem to another theorem, to judge the same answer. If the answer is correct from one theorem to another theorem, obviously you are proceeding in the right way. So much practice, much efficiency. So circuit theory is a very easy chapter, a very easy things happen, but much practice is required, otherwise in the examination hall you cannot complete the entire session. So when you are getting much grip, so you can easily toggle one problem to another problem, one method to another method, and if the result is same, you should not worry it about. Otherwise, if you are doing some kind of wrong in any sort of Thevenin's and Norton's, any kind of circuit theory problem, so obviously one particular problem, if traced with two consecutive or two successive methods, the answer can never be the same. So obviously you are doing some sort of wrong inside, otherwise it always having the same answer. Thank you very much. You all should have a very prosperous time in future, and more video I will be publishing on this type of Millman's theorem or the superposition theorem, different network theorems in the different university level questions and the gate questions very soon in my channel. So please go through it very deeply, carefully. You better take some footnotes to understand it clearly, and wish you all the best for the future forthcoming. In the next session of the circuit theory class, we will be discussing the two-port mechanism. So what is two-port network and what is activity and details thing. So wait for my next lecture and see you very soon. Thank you very much. Goodbye.